So now we're moving on to lesson 2.2, doing the basics of graphing. This is a relatively short section. So we're going to dive straight in. We've got the rectangular coordinate system. That's the one you know and love. That's the x-coordinate, y-coordinate pair. And we're going to convert some data into graphs and then take a look at some. So what I have first are two examples of time series data where one of the variables is time and the other is whatever it is you want to measure as time is moving. In this case, we're looking at the unemployment rate for the United States starting in 1993 and going up to 2018. That was when that's when this data was last measured for the book. So you can see that each of these pairs of information, the year and the rate, are combined into a single point. So let's take a look at the graph. And on the x-axis, we see the year, and then on the y-axis, we see the percent unemployed. So for example, let's take a look at this first data point. In 1993, the the unemployment rate was 6.9%. So that means the point 1993, 6.9 was created. If I go down to my data, I do like how the graph does not start at 1993. 1993 is out here. And then if I run up, I find myself at a height of 6.9. So 1993, 6.9. Another thing you will see in future problems, whenever you have a year, whenever you're dealing with time in years, that's 4 digits. And it makes graphing it, if you want to represent it on a graphing software, if you want to put it up on Desmos or something, you have to move the minimum x value from 0 to 1993. So sometimes what you'll see is instead of the actual year, what they'll do is they'll take the first year that they have data and they'll call that year 0. And then the time, this will be years since 1993. And there's 2 reasons to do that. So there'll be 0, 1, 2, 3, 4, and you get the point. The reason for that is, like I said, the data window or the graph window has to be changed. But the other reason for that is if I wanted to create a line of best fit for this, it's a whole lot easier to work with x values 0, 1, 2, 3, 4 than it is to mess with x values 1993, 1994, 2000, 2001, so on. So yeah, so there's the data. And what are we seeing? Unemployment rate is down. 2000, we see a spike. 2001, we get 2005. Then we see the Great Recession. Unemployment rate goes up. And then as time, it continued to go down through 2018. So let's get some definitions down. Let's get some information in here. On both axes, we see the numerical data, so it tells us what the value are, and then it has a title telling us what it's representing. So the x-axis is years, the y-axis is the unemployment rate in percent, and this helps us out to deal with scale. So notice that I didn't graph the unemployment rate from 0 to 100. Because there's no data point that needs that much space. The highest unemployment that I see in the data is still below 10%. So this is a good way to put your graph to scale. And the scale here is very helpful because it allows us to see a pattern or allows us to see some movement, whereas if I zoomed out and I was to graph this from 0 to 100, the changes would look so small you wouldn't even notice them. The numbers along here are on the axis, and again, it's really nice to see them. It's very good to label them because if these weren't labeled, you might assume that, well, each notch is worth 1%, but they're not, they're worth 2. So it's always required to label not only what is that axis representing, but then what is the scale for it. Location of these is from the rectangular graphing system. What that means is based on the any data point that you've plotted, I can then go from that, from the axis, excuse me, from the origin up to that point and create a rectangle. So this, I went to the right 1993 units and I went up 6.9 units. So now I have a rectangle. Every one of these points can correspond to a rectangle where the data point is at the top right and the origin is at the bottom left. The numbers used to graph are called coordinates. So yeah, this is a coordinate. This is a coordinate. And I remember somebody showing me, this is what it was originally, coordinate, right? This is an ordinate, this is an ordinate. So they're coordinates. There are two of them, right? So each of them are coordinates. So we just kind of mash that together. We just have coordinate. And then, like I said, the axis is the axis. I keep saying axis, and I mean origin. The origin's down here at the bottom left. The origin is the point 0, 0. Now, there is a big jump right here from 0 to 1993. What you would normally see in a textbook, if your x values don't start at 0, you might see a little line there, a little break, just to show the reader, hey, I'm not starting at 0, I'm skipping a whole bunch of numbers before I get there. So based on this information, let's see if we can plot some points. I've got 5 here, so we're going to start out with 4, 0. So remember, all the coordinates are x comma y. So this means to plot a point, I start at the origin. I move left or right based on the x value, and then I move up or down based on the y value. For this one, x is 4, so I start at the origin and I move to the right 4 units. And then y is 0, so that means I do not move up or down at all. Next is 0, -8. 0, so I start at the origin. I do not move left or right because x is 0, and I move down 8 because it's negative. So a negative y value means move down, a positive means move up. A negative x value means move left, a positive means move to the right. Next, -3, -4. I do make the change, I make my move left or right first and then down, not because it would give you a different answer, but because it's always better to have a procedure or process, so that way you don't forget how to do this one day, or you start doing it down and then left, or up and then right. Always do your x first and then your y change second, because that's the order the coordinates are given. 2, 7, right 2, up 7, and then -4, 5, -4, move left 4, and then up 5. If this looks familiar, it should. This is just more of that rectangular coordinate system. And if you're looking at this, you're thinking, isn't there something about these quadrants? Yes, there are. I can take and split up my real number plane here into the four quadrants, 1, 2, 3, 4. And what's unique, or why we split them up, is because every point in quadrant 1 is going to have a positive x and a positive y. Everything in quadrant 2 is going to have a negative x and a positive y. Everything in quadrant 3 is going to be negative x and a negative y, and then everything in quadrant 4 is going to be positive x, negative y. If it lands on the axis, it's not in a quadrant, so don't worry about those, like the points here, 0, -8, and 4, 0, because they're not in either of the quadrants. I do want you to take a look, though. If I were graphing a line and I landed on the x-axis, this would be my x-intercept. If I landed on, whenever I had a point, if I landed on the y-axis, this would be my y-intercept. And notice those forms. That's going to come up again later. Now, I talked about the scale, the axis. Why do we need it? here's an example. What temperature is this thermometer reading? All right. So right now, I have no idea. I don't know why this is here. It's not meant to be any label, but that's the problem. I don't know the temperature because the scale is not labeled, right? In Fahrenheit, I'm over here to the left. In Celsius, I'm over here on the right. None of these dashes, none of these hash marks are labeled, right? We can make an educated guess, but the only thing I can get directly from the thermometer is it's kind of warm. And I don't even know what kind of warm means. I have no idea. I know for Fahrenheit, we freeze at 32, we boil at 212, but I don't really see a place where that happens. Since it's not labeled, I really can't say what the temperature is. All I can say is it's warmer than, I really don't even want to say anything at all, just because it's not labeled. So always take the time to label these because, I mean, imagine getting a thermometer that didn't have the numbers on it. It'd defeat the entire purpose of a thermometer. In the same way, what is this point? What are the coordinates of this point on this graph? Well, they gave me the graph, and this looks like the point. I move left 2, so that's -2, and then I move up 4. So it looks like -2, 4. Okay, but that's not all the possible answers. Each one of these hash marks might be worth 2 units. So is 2 units. Then the point would be -2, that'd be -4, comma, and then I move up 2, 4, 6, 8. What if each one's 10? Then if each of them is 10, then this is -20, comma, -40, or excuse me, -20, +40. So again, must label. For a scale. So we have an idea that we know what's going on. The X and the Y can have different scales as well, right? X, you could have a different scale on the X axis than you do on the Y. X may be by 1s, but Y may be by 10s or 5s, just depending on the graph. So the whole point here, you must label and give yourself a scale. So what are the features of a good graph? Just like we said, labeled scales on each axis. And then there's no reason, like I just said, that there's no reason the scale has to be the same on both. If I'm like for instance, the problem we just did with the years, along the bottom, it's years, or along the x-axis, it's years. So I started at 1993 and I go up, and then on the y-axis, all I was doing is 0 to 10%, right? So I could have had the years, it could have been by 2 years or 4 years or 6. So taking a look at the example in number 2 there, points like 10, 4,000, and 23,000 would be tough to graph if I tried to do both my x-axis and my y-axis with the same scale, right? I would have my x-axis maybe jump by, maybe each hash is worth 2 or 5, but then for my y-axis, I'd probably want each hash to be worth 1,000 just so I can get to 4,000 without having to draw a graph that's just enormously tall. All right, and then lastly, if there are certain points on the graph that are important, take the time to label the coordinates, right? That's what we did every time. All right, and then lastly, we're going to do this example. I have some data, and it's dealing with the gas price of gas, and what they've done is they've done this for every year since 2006. So in 2006, they got the average price of gas in January was $2.32 a gallon. So notice that I also have the year, and then I have years after 2006. This is exactly what I talked about before. So the ordered pair here is actually going to be 0, 2.32 because 2006, 2.32 is much more difficult to graph and doesn't show up on the kind of the home screen. If I went into Desmos and plotted this, it would not show up because the x value would be all the way to the right at 2006. So I'm going to do a couple of these. 2.27, 2, 3.05, and you can see I'm just taking what's in this second column. That's my x coordinate. What's in the third column is my y coordinate. So 3, $1.79, 4, $2.73, 5, $3.09, and so on and so on. And then I'm going to run on here and plot them. I'm just going to plot those 5 or those 6 to start, and then you'll see how it goes. Average gas prices, and then along the bottom, these are years since 2006, and then this is price in dollars. All right, so what do I have? At year 0, which was the year 2006, gas was $2.32. So 232, halfway between 2 and 2.5 is 2.25. So I need to be a little above half. Next, 1 at 227, which is just below that. 2 is at $3.05. So here's 3. 305 is going to be pretty close to the line. At 3 years, it was $1.79. $1.79 is going to fall just above halfway between $1.05 and 2. Year 4 was $2.73. $2.73 is just below $2.75, so just about halfway. Year 5 was $3.09, so up here. And then I've got the rest of the points as well. Year 6 was $3.40. And then year 7 was $3.35. Year 8 is $3.32. Year 9 is $2.11. 2.11, and then year 10 was $1.97. Okay, and then we connect with straight lines. Okay, if you've got I've tried to draw lines on here before with the geometry or with the feature, and it just does not do it justice. And I can't exactly put a ruler on the screen. So let's see if we can get it. There we go. Down there, up here. Why do we need to connect the dots? It helps us to visualize what's happening between each year, and also how steep the line is that connects 2 dots tells us how much did it change a lot over those 2 years, and which direction did it change. So from year 1, which was 2007, to year 2, we see a pretty sharp increase in price, and then from year 2 to year 3, we see a sharp decrease in price. Not as sharp as from year 8 to year 9. So that's why connecting those with straight lines helps out.